Hello, in this video we'll be looking into the applications of the nomenclature rules. So if you're not aware of the nomenclature rules, then please do refer to the previous video where I explained the rules. So a quick summary of what we talked about in the previous video. We talked about the rules, we talked about how to identify the word root and the lowest number or the sum rule. We looked into the functional group and how to decide which one is the prefix or whether it's the functional group should be as a suffix. We also looked into that the numbers need to be separated by commas and a number in alphabet with a dash. So if all this seems a bit weird and confusing to you, then I would recommend please to watch my previous video on nomenclature rules. And if you're confident, then we can go ahead and look at some of the examples whereby we apply the rules. So let's look into these compounds, alkanes. So looking at the first example, you can number the compound from this direction. If you number the compound in this direction, we've got 4 carbon atoms. So straight away we know it's a bute, as the word root is bute. All straight chain, it means butane. Now you've got a side chain at position 2, but using the lowest number rule, we need to check which number is the lowest, and that's the numbering we pick. So we get 2, position 2, it's 1 carbon substituent, so it's 2-methyl butane. Now if you look at this one, we do the same thing. We identify the longest chain, so 1, 2, 3, 4, 5. We've got pent, all is single chain, so it's a pentane. Now we need to find out the sum rule. So this side numbering gives me position 4 and 3 for the substituent, number 7. When I number from this side, I have got position 2 plus 3, which is 5. So I'll pick this as my numbering. So I've got at position 2, I've got methyl. At position 3, I've got methyl as well. So I'll add them up, and now I will write 2, 3 dimethyl followed by pentane. So that's how you name some of the compounds. Let's try another example. You could pause the video now and do it. Otherwise, you can watch me do here. So solve this question. So we got 5 carbons, so that's a pent, all single bond, pentane. Position 2, we've got a methyl group. So at position 2, we've got 1 methyl group. At another position 2, position 2, we got another methyl group. So you merge them together, and you've got to number it twice. So you write 2, 2 dimethyl pentane. Now we've got this very highly branched compound, so we've got to check the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's going to be a pentane anyway. So it might be that I just pick that as the longest chain. So just to give me clarity. So if I number it from this side or whatever, it's a pentane. Now if I number it from this side, I've got position 3, I've got 2 substituents, and I've got substituent at position 4, so total is 10. Whereas if I number it from this side, I've got 2 plus 3 plus 3, 6, 7, 8. So I would pick up this numbering. Now on position 2, I have got methyl. I've also got another methyl at position 3. At position 3, I've also got ethyl. Now, when you merge these together, so it's 2, 3 dimethyl, and then I've got 3 ethyl. Now, when you write down the name, you write down ethyl before the methyl because of the alphabetical order. So 2, 3 dimethyl pentane. Remember, between the alphabets is a dash, so that's how you would name the compound. You've got next compound here. Now this has got double bond, so 1, 2, 3, 4. So this is a bute. Double bond means ene. You would need to indicate the position of the ene, but because this is 1 carbon, so you can let that go. You would start, you've got 1, 2, 3, 4, 5. So this is pent. Now you've got to give the numbering in such a way that the functional group gets the lowest number. So on this side, you've got position 2, which is lower than position 3. So you start numbering this way. So it's pent 2-ene. So it's pent 2-ene. Remember, I'm dropping the A from the end. So it's not penta-ene, it's pent 2-ene. Now at position 3 and 4, I have got my substituent. So the name would be 3,4 dimethyl pent 2-ene. In this compound, I have got CH3, so I'll look at my longest chain. So that looks quite long there. But if I see 1, 2, 3, 4, 5, 6, but the problem is you need to have the double bond in your parent chain. So you cannot use the parent chain of 6, but right now I would only have 5 carbon atoms in the parent chain. So this is a tricky one. So this is pent-ene and the ene is in position 1. So I would have to number from this side. So you've got to be careful. So 1, 2, 3, 4, 5, 6. Sorry, this would be hexene then, isn't it? So I've got hexene. So 6 carbon atoms, and I would use that. Now, because I've numbered from this side, on position 2, I have got an ethyl group. And on 1, 2, 3, 4, 5, at position 5, I have got a methyl group. So at this point, I've got 1, 2, 3, 4, 5, 6. So I've got 2 ethyl. I've got 2 ethyl, 5 methyl, hex 1-ene. Okay, so it's 2 ethyl, 2 ethyl, 5 methyl, hex-ene. So the reason why we've named it like this is you need that carbon 1, 2, 3, 4, 5, 6. So at position 2, we've got that ethyl group. If you look at this compound, it's got 1, 2, 3 propene. So we would number it from this end. So propene, I don't need to put 1. On this compound, we've got 1, 2, 3, 4. I've got 4 carbon atoms. So it's bute, and the double bond is on position 2. So it's bute 2-ene. And on position 2, I've got a methyl group. So I call it 2-methyl bute-ene. Alcohols. So let's look into the alcohol. So you've got to give the alcoholic functional group a lower number. So if I start from this side, it gives it a lower number. So this, I've got 4 carbons in it. So bute, all single bond and I've got functional group all. Alcoholic functional group is always with the all. And because the alcoholic functional group is at position 2, you call it butanol. You got a prefix, so I would use a small b for that name. Position 3, I've got methyl, so this is 3-methyl butane 2-ol. In this compound, I've got again 1, 2, so I'll start with this 1, 2, 3 carbons. So this is propane all. I don't need to put 1-ol. At position 2, I've got methyl, so it's 2-methyl and small p propanol. Long chain, so you would start numbering from the side so that the alcoholic functional group gets the lower number. So 6 carbon means it's hexane, and I've got 3 position all, hexane 3 all. I've got 2 methyl groups at position 4 and 5. So you would write both numbers 4, 5 separated with a comma dash. I would do dimethyl hexane 3-ol. Carboxylic acid. So this is the functional group. With carboxylic acid, you would start with that carbon. So you include that carbon. This is propanoic acid. So because it's functional group, it's given always number 1. Now in this compound, you would think the longest chain 1, 2, 3, 4. So I could use that because the 1, 2, 3, 4, 5 is long, but it needs to include the carboxylic acid. So 1, 2, 3, 4, 1, 2, 3, 4. So either way, it gives me 4. So it's butanoic acid because I've got 4 carbon. Functional group is given position 1. Now at position 3, at position 2, I've got ethyl. At position 4, I've got 2 methyl groups. You put them in alphabetical order. Ethyl comes before methyl, so 2-ethyl. Then I've got 3,3 dimethyl, 3,3 dimethyl butanoic acid. So that's the name of that compound. Aldehyde, so CHO group is aldehydic group. Include that in the parent chain. Give it lower number. So I've got 4 carbon means but, all single bond, carbon-carbon. We're not looking at this bond, but all carbon-carbon bond is single, so butane. And aldehydic functional group is al. You don't need to put 1 L, but butanol. Now at position 3 is methyl, so now I write 3-methyl butanol. This compound, again 1, 2, 3. So this has got 3 carbon chains, so prop, all single bond, and aldehyde, so propanol. Ketone, I've got 1, 2, 3, 4, 5, 5 in the chain. So you always start with numbering from this end. So you will have ketonic, so it's pen-10, 2, own, because at position 2 is the ketonic group, but position 4 is methyl, so 4-methyl pentane 2-on. Same way, when you look at this one, this is just butane, no. Halogenoalkanes or haloalkane, halogen is always the prefix, so this is bromoethane, longest chain, and you will name the compound. All the prefixes would be written in alphabetical order, and you would get 3-chloro, 2,2 diiodobutane. So that's how you name haloalkanes. If any of this is confusing, then I would recommend that you go and revisit the previous video where I have explained the summary of the nomenclature rule. So I hope this has been useful. And again, if you need to look at the previous video, please do spend some time writing down, practicing writing the names of organic compound using these rules. So I hope this video has been useful. Thank you for watching and all the best. Thank you.